Hello, boys and girls. This is the video for lesson 15 in module 1 of Eureka Math. And we're going to start today by doing a little bit of multiplication. So 5 times 4. How can we figure this out? We can skip count by 4s. Let's try that. Ready? 4, 8, 12, 16, 20. Okay, so I counted by 4s 5 times, so my answer is 20. Let's try it again for 4 times 4. So this time we're going to still count by 4s, but we're only going to do it 4 times. Ready? 4, 8, 12, 16. So 4 times 4 is 16. Now, since I already knew that 5 times 4 was 20, and I know that 4 is 1 less than 5, I could start at 20 and count backwards by 1 4, and I would come to 16. So if I started with 20, let's count backwards 4, 19, 18, 17, 16. So I could do it the opposite way. What if I wanted to do 4 times 3? Okay, I know that 4 times 4 is 16. I now have 1 less 4. Instead of 4 4s, I have 3 4s. So if I took 4 away from 16, let's count backwards. 15, 14, 13, 12. I can figure out that 4 times 3 is 12. So I want you to do 4 times 2 by starting at 12 and counting down, counting backwards by 4. So 12, you're going to count backwards by 4. Go ahead and try that on your own. Okay, how'd you do? What'd you get? That's right, it's 8. Because 12, 11, 10, 9, 8, when I counted down, I got to 8. All right, let's do a little group counting by 2s. So this is, you are getting really good at this. So let's go ahead and do it pretty quickly. So let's count by 2s. Ready? Go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And now backwards. 18, 16, 14, 12, 10, 8, 6, 4, and 2. Good job. All right, you ready to count by 3s? All right, here we go. Ready? 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Ready to go backwards? We start with 30, 27, 24, 21, 18, 15, 12, 9, 6, 3. All right, fantastic job. Okay, let's look at how arrays relate to tape diagrams. So I'm going to draw an array with 2 rows and 4 columns. Okay, 2 rows and 4 columns. So remember, rows go across, columns go up and down. So 2 rows. So here's the beginning of row 1. Here's the beginning of row 2. And then I need 4 columns. Okay, so go ahead and draw this array on your whiteboard or piece of paper. 2 rows, 4 columns. Yeah, I'll give you a second to do that. Okay, you can tell me a multiplication sentence that we can make with this array. That's right, we could say 2 times 4 equals 2, 4, 6, 8. Now what if I took my array and I turned it this way? You can do that on your whiteboard. I can't really do that on my whiteboard because it's attached to the wall. But if I took this array and instead of having 2 rows of 4 columns, I had 4 rows with 2 columns, would I still get the same answer? I would. I could flip my numbers around because of the commutative property. And I would get 4 times 2 equals 8. So it doesn't matter which direction we put it in, it's still the same. Okay, let's draw a tape diagram for each one of these equations. So 2 times 4, I'm going to draw a tape diagram with 2 sections for my 2. And I'm going to put 1, 2, 3, 4. 1, 2, 3, 4. It's kind of like a domino. So I have 2 sections with 4 each, which gives me a total of 8. What about this one? Let me draw a tape diagram with 4 sections. Then how many will I put in each section? That's right, only 2, because I already used my 4. All right, so in this case, we have 2 here. Oh, I made a mistake up here. 4. Sorry about that. 2, and we still have a total of 8. Okay, so we can flip our array. We can't really flip our tape diagrams because we made them differently. This one had 2 sections, while this one had 4 sections. 2 sections of 4, 4 sections of 2. Okay, let's look at another array. This time, instead of 2 rows of 4, I'm going to make 5 rows of 4. Five rows of 4. Who can tell me a multiplication sentence that can represent this array? What could it be? You're right, it could be 1, 2, 3, 4, 5 times 4. And how much is 5 times 4? I can count 5, 10, 15. Oh, wait, 4, 8, 12, 16, 20. Or if I want to count by 5s, which I like because that's easy for me, I go this way, 5, 10, 15, 20. And because of the commutative property, I can turn my array the other way and then what's my other multiplication sentence? Right, it was 4 times 5. Okay, on your whiteboard or paper, I would like you to draw 2 tape diagrams. One that shows me 5 times 4, one that shows me 4 times 5. Okay, I'll give you a minute to do that. 2 arrays, 2 tape diagrams, one for 5 times 4, one for 4 times 5. So 2 tape diagrams. I wasn't very clear about that. Tape diagrams, one for 5 times 4, one for 4 times 5. Okay, while you're doing that, I'll do mine and we'll compare and see how we did. All right, so here I have 5 times 4, where I have 5 sections with 4 in each box. And let's count by 4s and see what our total is. 4, 8, 12, 16, 20. Here I have a tape diagram with 4 sections with 5 in each section. Let's count by 5s. 5, 10, 15, 20. So once again, we see that the commutative property is correct. It allows us to move our numbers around in a multiplication sentence. All right, let's take this one just a bit further and review a little division. So can I write a division sentence that goes with this multiplication sentence? What do I always start with in the division sentence? Let's write the largest number. So I know I'm going to start with 20. And I divided it into how many groups? Groups of 4. And my other one, I divided it into groups of 5. Okay, so we can switch these numbers around, but we always have to start with our largest number in division. Let's take a look at the problem quickly. And let me share that with you. Okay, I think I've got it. So this is our problem set for lesson 15. Let's take a look at the first one. We're going to be labeling tape diagrams and completing equations just like we were doing together. So let's look at A. In our top tape diagram, we have 2 sections with groups of 4. They've labeled the 4 for us. What are we going to put in this box right here? That's right, we're going to put an 8 because we have 1, 2, 3, 4, 5, 6, 7, 8. And then that will show us that 2 times 4 equals 8. Okay. And let's look at the next one. Now we have it flipped the other way. Now we have 4 groups of 2. What's still going to go in this box?
That's right, it's still going to be 8 because 4 times 2 is 8. Okay, and then don't forget this part. Draw an array to represent the problems. Okay, so I could have drawn 2 rows of 4. What else could I have drawn? That's right, I could have drawn 4 rows of 2. It doesn't matter which way, it would still be the same. All right, let's look at B. So B, here I have 1, 2, 3, 4 things in this first section. So I'm going to type a 4 in this top box. Okay. Then what would I type in the bottom box? Even though they haven't filled these in, we're going to assume that these are the same because we're doing multiplication, so we have to have equal groups. So if I had 4 flowers and I had 3 boxes of them, how many would I have altogether? 4, 8, 12. Very good. So we put 12 in this box. Okay, I have 4 flowers. I'm going to use my number from up here because I have 1, 2, 3 boxes. 3 times 4 is 12. Then I'm just going to do it the opposite way here. I have 3. I'm still going to have 12. And then I'm going to turn it around to say 4 times 3 equals 12. All right, you can go ahead and do C on your own. Okay, number 2 wants you to draw and label 2 tape diagrams to model why the statement in the box is true, that 4 times 6 is equal to 6 times 4. So we're going to do just what we were doing up here and what we were doing on the board. 2 diagrams, one direction, one for the other direction. Okay, and then a couple more problems, and that's it for today. Okay. Find you again. There you are. Okay, so that is your math assignment for today, Friday, September 11th. And I hope you have an awesome weekend, and I will see you next week. Bye-bye.